Hey everybody, so we're going to go through this same process again of getting all the information that we possibly can out of this equation before we start graphing. And again, it's the same process every time. I start by looking at the equation as it's given. And the equation as it's given tells us about the end behavior, which is the horizontal asymptotes, if there are any, on a rational functions graph. So I'm looking at the degree of the numerator and denominator. They're the same, which tells me I should be looking at the ratio of the leading coefficients. 1 over 1 is 1, so y equals 1 is the horizontal asymptote. Given the equation in this form, I can also easily find the y-intercept. If I plug 0 in for all the x's, I get 2 over negative 2, which is -1. So when I plug in 0, I get -1. So that's my horizontal asymptote. And now I'm also interested in my vertical asymptotes and my x-intercepts, and that can be found when this is factored. Now the numerator does not factor because it's x squared plus 2. So this stays x squared plus 2. And if I really think about it, is there any number you can think of that when you square it, which makes it positive, and then add 2 to it, I said 2. When you add 2 to it, I did it again. Can it possibly be 0? Can you square a number and add to it and get 0? I don't think you can. And so as far as x-intercepts go, there are none. So I should not cross the x-axis at all in my graph, or even touch the x-axis. I think that's the better way. I should not touch the x-axis at all during my graph. But the denominator, does this factor? I haven't really thought hard enough about it. What multiplies to give me -2 and adds to +1, +2 and -1 works. So there's vertical asymptotes. At x equals -2 and x equals 1. All right, so I don't have a whole lot of information to go off of here. So I'm probably going to need a little bit more from this. So what I mean by that is if I draw a rough sketch here, I have a horizontal asymptote at 1. I have a vertical asymptote at -2. I have a vertical asymptote at 1. I know that I'm crossing the y-axis here at -1. Now, if I'm not going to cross the x-axis at all, that kind of helps me out a little bit, because that means I can't start up here, because then to get to this point, I would have to cross the x-axis somewhere. So instead, that means I must be starting here and doing something like that, okay? Just a basic shape. Now, the vertical asymptotes were created by these two factors, x plus 2 and x minus 1, and each of these factors have an exponent that is odd. It's 1. It's an odd exponent. And that tells me that since I'm going to -infinity over here, I must be coming from +infinity up here, which gives me that shape. And I must be coming from +infinity here. Now, how do I know to level off here? Because that's what the horizontal asymptote is all about. It means I am approaching 1 as we go to infinity or -infinity. I should be approaching this line. Now again, it could have happened in this fashion maybe, as long as I don't touch the x-axis at all. It could happen that way. And if you're really curious, you can always just put this in your graphing calculator and see what it says. I would be fine with this answer. I know Pearson MyLab might be a little bit more specific, but I don't think you're actually going to be graphing these on Pearson MyLab because the software doesn't even handle that. It can't even handle that. So instead, you're going to be picking the graph from a multiple choice. And if there's two if there's one that looks like this graph that you're seeing in front of you, and there's one that looks like this in red, and they both seem plausible, then you might want to just plug in a point over here. Let's say this is, since this was -2, let's say this is -3. Okay, just plug in -3. And if it's less than 1, then you know that you approach this from underneath 1. If it's greater than 1, then you know you approached it from above 1. And that'll tell you, that'll give you that extra piece of information that you might need. All right, so I'm not even going to take the time. This graph, I think, that I sketched here did its job. So I'm not going to graph it formally. Let's just do one more example. And I know all the examples we're doing here, the coefficient in the numerator and denominator were the same. But just be aware that if the denominator has a higher degree, y equals 0 would be that horizontal asymptote. That doesn't mean there can't be any x-intercepts. It just means that towards the end, you're probably not going to see any x-intercepts. So let's go ahead and, again, let's pick off some characteristics. We know that the horizontal asymptote is going to be determined by the leading coefficients. So y equals 1 is the horizontal asymptote again. And it also looks like the y-intercept is 0, because I get 0 divided by 1. So if I plug zeros in here, I get 0 divided by 1. 0 divided by 1 is 0. So this is a y-intercept. It's also going to be one of my x-intercepts. And I think it's going to be the only x-intercept. But what do you notice about this x-intercept? The x-intercept is 0, 0, but it has a multiplicity of 2. I'm also noticing that the denominator is not factorable. And if the denominator is not factorable, that and the fact that I'm squaring a number and adding 1 to it, there's no way I'm going to get 0. So there are no vertical asymptotes for this problem. And so what do we have here? We have a graph where y equals 1 is a horizontal asymptote. There are no vertical asymptotes. The x and the y-intercept are the origin. This is the only place it can touch the x-axis, and it's going to touch the x-axis and bounce off. And so with all of that information, this looks like the only likely scenario for this graph. Now again, I'm not discounting the fact that this could have happened. That could have happened. But I just think it's less likely. I'm not saying it's impossible, I just think it's less likely, that's all. Especially since the denominator is always a little bit bigger than the numerator. So as I'm going to infinity, the denominator's a little bit bigger, so I'm always a little bit smaller than 1. Like if I plug 10 into here, I get 100 over 101. So I'm not quite at 1, I'm at 0.9999. Like I'm getting closer to 1 from numbers that are smaller than 1. And that same logic works going in the negative direction. So I'm confident in my blue graph here, and you can think about the same sorts of things that I just mentioned as you go through the problem set. I would also recommend maybe doing the problem set problems that have to do with like polynomials and quadratics first, and then watching the next video, and then doing the problem set problems that have to do with that part. So in this case, rational functions. I probably should have mentioned that in the first set of videos. You can always save and come back to your work on Pearson MyLab. So if you wanted to break it down into watching the videos for part of it, doing the problem set, and then coming back to the videos and doing the problem set, they're pretty much in the order that I cover them in the videos. All right, so I will see you in the next group of videos for talking about